Hello class, today we're going to be going over lesson 5.4, how to solve systems using elimination. So again, just for a recall here, remember guys, when we are trying to solve a system of equations, what we're trying to find out is where two lines intersect. Like for example, these two lines would intersect right here, so this would be the system or the solution to my system of equations. Alrighty, let's get going here. So elimination, this is our definition for us today. To solve a system of equations using elimination, you need to eliminate or cancel out one of your variables by adding or subtracting our two equations. All right, so real quickly, I just want to do one for you guys as an example, and then I'll explain the rules to you of how we will solve these. Okay, so to solve a system of equations by elimination, the first thing we need to do is line up our x's, line up our y's, and line up our constants. So notice all of my x's are in one row, all of my y's are in, one column, all of my y's are in one column, and all of my constants, my numbers, are in one column. Okay, so now that they're all in one column, what I need to do is I need to cancel out one of these variables by adding these two equations together. So notice, if I add these two equations together, a negative y and a positive y will turn out to 0. Let me show you why. So if adding them together, this is why we want to stack them up and down. X's above x's, y's above y's, and constants above constants. So here I have 3x plus 2x. Well, 3 plus 2 is 5, so I get 5x. Negative y plus positive y is 0, so I get a plus 0. And that'll be equal to 8 plus 7, which is 15. So I get 5x is equal to 15, basically. And when I divide by 5 on both sides, I will get x is equal to 3. Alrighty, so now that I've solved for one of my x's, what I need to do now is I need to go take that x, I need to plug it up into one of the equations up here. So I'm going to use the equation 3x minus y is equal to 7. And I'm going to take my x and I'm going to replace it with what I solved for x, which was 3. So I'm going to replace my x with 3. Now I have 3 times 3 is 9, so 9 minus y is equal to 7. I'm going to add y to both sides, so I get 9 is equal to y plus 7. And when I subtract 7 from both sides, I get y is equal to 2. Alrighty, so now that I've gotten an x and a y, that is the solution to my system of equations. I can write it as a coordinate as x comma y or 3 comma 2. Alright, so that might have been a little bit confusing to some of y'all. So what I want to do now is I want you to write down the steps of how we solve the system of equations. So step 1, you need to line up your two equations so your x's are on top of your x, your y's are above your y's, and your constants are above your constants. So whether that means rearranging your equation, whether that means just simply using the commutative property and moving it around, you need to have your x's, y's, and the constants all in columns above each other. All right, next, you need to add or subtract your like terms to cancel out one of your variables. So note, if you cannot cancel one of your variables, as in there's nothing where if you add it together, you subtract it together, one of your variables will go away, then you need to multiply one of your equations by a constant so that way you can cancel them. I know that sounds a little bit confusing, but we'll have an example for that in a second. All right, step 3, solve the resulting equation for your remaining variable. So that's kind of like in the last side where I had 5x is equal to 15. I divided by 5 on both sides to get x is equal to 3. And the last step is you want to plug in your solution for whatever you solve for x or y into one of the equations, and then you want to solve for the remaining variable. Alrighty, everybody, so I'd like you to pause this video, make sure you get down those 4 steps, but now we're going to go forward and do some more examples here. Alrighty, so here I have an example of 2x minus 2y is equal to negative 4, and 2x plus y is equal to 11. So notice here, my x's are above my x's, my y's are above my y's, and my constants are above my constants. So what I'm going to do here is I notice that if I do 2x minus 2x, I can cancel out my x terms. So what I'm going to do is I'm going to subtract my two equations. So 2x minus 2x will give me 0. 2y minus y will give me a negative 3y. And negative 4 minus 11 will give me a negative 15. So I get negative 3y equals negative 15. Or, negative 3y equals negative 15. All right, so to cancel out multiplying by -3, I'm going to divide by -3 on both sides, and that will give me y is equal to 5. Alrighty, so now that I found y is equal to 5, what I'm going to do is I'm going to go to one of my original equations, 2x minus 2y equals -4, and I'm going to replace the y with what I found y was equal to. Okay, so I have 2x minus 2 times 5 is equal to -4, or 2x minus 10 equals -4. By adding 10 to both sides, I get 2x is equal to 6, and by dividing by 2, I get x is equal to 3. All right, so now I've solved my system of equations here. I have my x comma y, or 3 comma 5. All right, so again, what we're doing here is we're just lining up our x's and our y's, and then we are either adding or subtracting our two equations. Let's go on to another example here. So notice in this example here, in 2y minus 5x equals -2, and 3y plus 2x equals 35, notice I don't have any x's or y's that are going to cancel, right? So what I have to do here is I have to make my x's and y's the same, or either my x or my y the same. So do you guys remember when we would work with adding fractions? No, remember when you add fractions? Like, for example, I can't add a fraction with a denominator 2 to a fraction with denominator 3. So what we had to do here is we had to make a common denominator by rationalizing it or by multiplying by the least common multiple. And that's kind of what we're going to do here. We're going to find the least common multiple besides these two numbers, and then we're going to both get those to that number. So let's look at our y terms. Let's look at 2 and 3. So what's the least common multiple of 2 and 3? Or what's the smallest number both of these numbers are going to multiply together to? Hopefully you guys are thinking it's 6. So what I need to do is I need to multiply both of these equations here by a number that's going to get the y term equal to 6. So for the top one, well, 2 times what equals 6? That'll be 2 times 3. And for the bottom one, 3 times what equals 6? That'll be 2. So I need to multiply both of these equations by 3 and 2 respectively. Now what that means is I basically need to distribute this 3 to all of the terms. Every term has to get multiplied by 3. So 3 times 2y would be 6y. 3 times -5 would be -15x. And 3 times -2 would be -6. Now on the bottom, I have 2 times 3y. Again, that would be 6y. 2 times 2x would be 4x. And 2 times 35 would be 70. Alrighty, so the reason we did that is because I wanted both of my y terms to be the same. Notice how I have a 6y on both of these problems now. Alright, so now I could subtract these two equations to cancel out my y terms. So 6y minus 6y will give me 0. -15 minus 4 will give me -19x. And -6 minus 70 will give me -76. All right, so I have -19x is equal to -76. Now to cancel out multiplying by -19, I'm going to divide by -19 on both sides, and that will give me 4. I get x is equal to 4. Alrighty, so now that I've solved for one of my x terms, what I can do is I can go to one of my original equations here. Let's use 3y plus 2x is equal to 35. So I'm going to take my x term here, and I'm going to replace it with what I solved was equal to x. So instead of my x, I'm going to replace that with 4. And I'm getting that from right here, x equals 4. So I'm taking my x right here, and I'm replacing it with 4. Alrighty, now I have 3y plus 2 times 4 is 8 is equal to 35. When I subtract 8 from both sides, I'll get 3y is equal to 27. Divide by 3. And I get y is equal to 9. Alrighty, so now I have my two coordinates here, and if I were writing my answer for this, it would be 4, 9. Okay, so I would like you guys to be able to try one of these out on your own here, I believe. Yes, I want you guys to try this one out on your own. X plus y is equal to 56, and x plus 2y is equal to 94. Kind of included some steps for you on the side here so you can follow this along, but I'd like you guys all to pause your video right now and try this out on your own. All right, if you guys are unpausing it right now and you want to see if you got the correct answer, let's find out. So I noticed that I can subtract my x terms from both of these here, and I'll get my x's to cancel. So if I do x minus x, I will get 0. Y minus 2y will give me a negative y. And 56 minus 94 will give me negative 38. So I get negative y is equal to negative 38. Or another way, y is equal to positive 38. I just divided both sides by negative 1. Or you can think add y, add 38. You get y equals 38. All right, so now I'm going to go back to one of my original equations here. X plus y is equal to 56. Except now my y is equal to 38. So instead of my y, I'm going to replace it with 38. So I get x plus 38 is equal to 56. By subtracting 38 from both sides, I get x is equal to 56 minus 38 is 18. So if I'm writing this as a coordinate, it would be 18, 38. Alrighty, everybody. Hopefully these notes were helpful for you guys here. What I need from you now is to write 2 complete sentences about what you learned tonight. 2 complete sentences. After you guys are done with that, if you have any questions, please bring them to class tomorrow. I will see you all then. Take care, everybody, and peace out.